Okay, so in an effort to hopefully make a little bit more of this hinge project make a little bit more sense, I was going to show you how to complete the box in Onshape. Fusion is going to be really similar. Doing it in Tinker is something I could make a video about if you want me to, but I'd like you to start trying to do more in like a CAD package like this. Blender is possible, but it's going to be outside of my wheelhouse to be able to show you that right now. So for now, here in Onshape, we'll create a new document, and we'll call this Hinged Box 1. Okay, so I'm going to make this fairly basic. So I'm going to sketch on the top for now and create a center point rectangle. Before I do that, I'm going to change the workspace units by pressing the little hamburger button here and then going into millimeter. So now when we, so I have to go back into that sketch and create a center point rectangle. And I'm going to make this 75 by 75. The requirements are 100, essentially 100 by 100 by 100. So this will definitely stay inside of there, even with the hinge and all that kind of stuff. And we will extrude that. And we'll extrude it up 50 millimeters, and then we'll make a 25 millimeter lid here in a second. And just to kind of see that it's a box, I'm also going to add the shell command, and I'm going to pick this top face, which is going to hollow that box out. 2.5 millimeters is a good shell distance for the box, so we'll leave it at that. So now I need another part, so I'm going to create a new part style, part studio, and again create a sketch on top. And I'm going to create another one of those rectangles and make it 75 by 75. Finish that, extrude it by 25 this time. So now we've got a 50 millimeter tall base and a 25 millimeter tall lid, and that's 75 millimeters, so that'll work. And we'll shell out the bottom of this. So you could just do these two parts. You can do it in Part Studio for both of these. I like to do it in or create an assembly mode so I can see that things are going to line up okay. So if we go to the assembly tab and then hit insert, and we want to pick our two parts, hit OK, and then I'm going to grab the bottom one and I'm going to move it up by 50 millimeters because that's the size of the base. And so now we have the top of our box and the bottom of our box. That'll help us to see how things align here in a little bit. So I'm going to go back to the base and I'm going to create the sketch for the part of the hinge that's going to be on the base of the box. So by doing that center point rectangle and picking the origin, I now know that the box is still centered here, which means the front and the side, or front and right axes, are slicing the model through the middle. And that's going to be helpful to me. I like doing it this way for creating the hinge because I'm going to create it on the front plane, which again, that slices that model right in two. And I'll show you why that's helpful here in a second. So I'm going to go to the front view and zoom up a little bit. Button. And we'll create a circle that's 2 millimeters in diameter. That'll be for the hole. And then another circle that's 5 or so. And that'll be for the geometry of the hinge. And I want to be able to base lines and things off of the side of this plane. So to do that, you can press the U key or this use, which is project or convert. And I'm going to pick that plane, and now I get a line that just ran through there. And that is a very helpful line because now you can see it's still there when I spin around. We go to front view again. Now I can create a line that goes from there to the endpoint. and from here to the circle. And then what I'll want to do is make these two lines that I just added tangent to the curve. So I'm going to pick one line in the curve and press the tangent key, or T, and then both of those. I can press T and make that tangent. And so now this circle can kind of move around still, but you see those lines, they kind of wig out a little bit every once in a while, but they normally go back to where they want. But I really want this edge and so the top of the box and the center point of the circle to be in line. So I'm going to pick those two and choose coincident. You see that drop down a little bit. So now I can't move it up and down, but I can move it left and right. But I really want to lock it down left and right. So I'm going to press the D key for dimension and go to the center point of the circle, that edge that I projected again, and I want to make this 3 millimeters. You'll notice most of these are black lines. That means they're constrained, but I do have one here that's still kind of iffy, right? You can move it around and do what you want with it. So I do want to lock that down. So I'm going to press D key again, and I'm going to pick those two edges and then say 45 degrees, because we know 45 degrees are going to print pretty well. It's going to be able to add geometry to that as it's printing. It's not too steep of an angle. So now we have the base geometry, or base idea for our hinge. And so I'll finish the sketch, and then we can extrude, not fillet, extrude this part and this part. Now I want this part to be centered on that the sketch plane, and so what I can do here is select symmetric. And so now it's shifted down, and whatever dimension I put in here will still be centered on that sketch plane, which is right in the middle of the design. And I'm going to make this 20 millimeters because it makes the math a little bit easier later. So now I'll finish that, and now we have our lower box part with the hinge. I come back here to assembly mode, we can see that did update, and so now I need to create the two ends of the hinge for the top of the box. So we'll come back to here, and we'll do something similar again. We'll sketch on the front plane, and I'm going to go to front mode. I'll press U again to project that line there. We'll use that again. And then we'll create another circle. Now this time for the circle, because I'm putting the circle on an axis that's of the origin, you can see we get that dashed line, and that's going to make it concentric already. So that's going to make our life a little bit easier on this one. And then we'll make that make our 2 millimeter and 5 millimeter circles. And then we can dimension from those two and say 3 millimeters again. And then we can add our two lines in. We need that line there and that line to that point. And we want to make these two tangent and these two tangent. And then we need to dimension these two and say 45. And now we're all done. So that was pretty painless, just recreating that one again. It's about the same thing as what we did before. The extrude is going to be a little different. So for the extrude, so I want to pick these two parts again, but I don't want it to start at the sketch plane. I want it to actually be offset by about 10 millimeters and then extend another 10 millimeters. So the depth, I'll say this is 10 millimeters here, but I want to do a starting offset. And if we do that, you can see it shifts that out 25 millimeters by default, and then the extrude starts. But we actually want to go out 10 millimeters and then extrude for 10 millimeters because we've got this 20 millimeter bottom part of the hinge here. So it's 10 millimeters on both sides. So we'll say OK to that and then create another extrude. Now our sketch disappeared, so I do need to turn the sketch back on again. That is a feature that it does where it thinks, well, you've already extruded something off of a sketch, so hide the sketch so you don't see all these 2D sketches everywhere in space. But if you want to do another sketch on that, or another extrude or command on a previous sketch, you have to turn it back on again. So now we want to, again, do that starting offset. We want to do it 10 millimeters, and we want to do a depth of 10 millimeters, but that makes it sit right on top of the geometry we just created, because I need to switch the direction. So I want to actually go extrude it in the other direction, but then also the offset needs to go in the other direction. So now it's going essentially 10 millimeters this direction, and then it extrudes 10 millimeters. And that arrow can really help you understand, for instance, if I don't switch the direction, it did the starting offset of 10 millimeters in this direction, but then it extruded it to the right here, and that arrow is telling you that. And so then if you just flip that direction around, it's looking how we want it to look. So if we go back to assembly view, it looks like a good hinge, but there's a problem. I'm going to continue harping on tolerances through the rest of this semester. You can see here that these two things are butting right up next to each other, and that's not going to work well. You could file it down or sand it down or something, but you don't really want to have to post-process it if you don't have to. And so to get this working a little bit better, we want to, one easy way is just to shorten this this base extension a little bit. So if we come back to here and double click on the extrude that we had done earlier, if we make this 19.6, no, not 19.8, that'll work, then that's going to give 0.2 millimeters on one side and 0.2 millimeters on the other side. It's not 19.4. 19.6. Yeah. Yeah, that's 0.4 millimeters. So then 2.2 millimeters on one side, 0.2 millimeters on the other. All right, there we go. So hit OK to that. And if we go back now to our assembly view, now you can see we've got a little bit of a gap there, which will work pretty well. So that's the main tolerance we're going to need to keep in mind when it comes to the hinge. And the lid should be pretty close to being able to just, I'm hoping, sit flush and work well. All right, so we have our box, but it's just a box. If we wanted to spruce it up a little bit, we can do some things like adding some decoration to like the corners. That's a super easy thing to do. So to do that, we could either add, let's go back to the base here. We could either add a curved surface to the corners, or we can add a straight cut, kind of angled cut to the surface or to the corners. A curved surface is not a great idea, and the reason for that is if we go into, that's called a fillet. If we add a fillet to the base of the model, and we look at this from the edge, the first layer is going to work fine, but then the second layer, it'll come up and it'll extend out too far, and it'll droop down and it won't look as good. And so the bottom of this curve, until you get up to about 45-degree angles, is going to look kind of weird. And so you don't really, again, want to fillet the bottom surfaces of your designs in general, not even just this box. So what we could do is we could add it instead of chamfer. And if we do that, that's going to add this blocky corner to it. And if we set that to 2 millimeters, you can see that is going to have a nice angle cut to it. It's going to print well because it's a 45-degree angle, and it's also going to kind of hide some of the elephant footing that we talked about earlier in the semester. So then what we could do is say, okay, let's chamfer these other corners also. Now you'll notice this is chamfering the shelled box. So if we want a bigger chamfer, let's say 7 millimeters, it turns kind of, I don't know what, magenta, whatever color you call that, because it's trying to chamfer and it's going to create voids. So it's saying that that's not a valid chamfer because you're wanting me to cut geometry that's not there. So we can leave that. We can just say, okay, we'll do it anyways. Now it doesn't. But what we could do is we could move it before the shell command. So I just clicked that chamfer and I moved it up above shell. So then that's saying do the extrude, then do the chamfer, and then do the shell command. And that way we get this kind of, I don't know, more extreme chamfer here, but then we also get these rounded, or not rounded, but sloped corners in the inside of the model, which can be nice. Now you don't have, corners for a little, I don't know, dust or dirt to get trapped into. And so that could be a nice feature if you want it that way. If we go back to assembly view, we can see here that doesn't really match anymore. And so then we'll go to the part studio for the top, and we can add in that same chamfer. Again, it's yelling at us about it, but that's fine for now. Okay. Press OK, and then we'll just drag that chamfer above the shell, and now it's shelled on the inside. Now, one thing I do want to point out, we're getting a one feature failed to regenerate error here, and the sketch is red. You sure? So if we double click on it, we can see that we've got all these kind of red warnings, and that is because of that use command that we did earlier. Because the use command was based on a face that now doesn't exist anymore. That face has now been chopped off because of the chamfer. And so this used line is now no longer valid. And so if we delete that, I don't know why there's another one there and there's another one out there. So now if we wanted to add that back in again, we could say use this surface now. And because we've also lost a couple of dimensions. So now we want to dimension again from the center point of the circle down here. So that's going to lock that all in. And we also want to dimension from here to here. So that'll lock that one in. Now this one's still blue down here because it's based on the endpoint of that use command. So if you really wanted to, you can select that select the point and that one, and no, not say coincident. You can delete this line and then just add it back in again. So it's going to lock to that point and to that one, and we're going to then select both of those and make them tangent again. Now this is probably going to break the extrude. Oh, it didn't. Okay, that resolved nicely, so that's nice. So now we have our shell, we've got our chamfers, hinges, and no red exclamation marks. We could go back and fix the sketch in this one. I'm pretty sure that's complaining. Yeah, see, that one's got a line that sticks down the bottom. So the one thing to keep in mind is, now that we know about the chamfer, maybe before we had done future sketches, we could have put the chamfer in kind of right away because we knew we wanted to do that. And then the use command would have worked better because we would have based it off of geometry that was already chamfered. Actually, we can go back in and let's just fix this one, because I do want to show you this does resolve some stuff kind of in an interesting way. So I pressed U, so now we have our line again, dimension from the center point again, and dimension this angle just to lock everything down. And again, delete that, put another line back in, and make it tangent. All right, so that's all locked down again. Finish that. Thankfully, the extrude did work again. So the thing is, the reason I wanted to do that is because maybe you're looking at this some more now and you're like, I don't really know if I like that chamfer. That's a little big. Or maybe you think, I want it even bigger. Now you can just double click on this chamfer and let's make it 15 millimeters. So now you've got really big chamfer. And the cool thing is that everything else updates. So now our sketch, you can see that use command fixed the line this time because that surface already existed. So it's able to kind of update it. And that's where you get some of the cool features of CAD, in that you can base or you can update things, and if it's able to, it'll resolve it pretty well. So you go back to assembly mode. Obviously, we need to tweak the lid. So now we can just go into our chamfer and say 15. And everything updates nicely. And our assembly looks pretty good. Okay, so now we want to get this box to the slicer. So there are two ways to do it. If you've done just the part studios, then you need to come into these part studio tabs, right click on the part and say export. From Onshape, I'm really finding that STLs tend to work better. So just export it as an STL, not a 3MF, and choose millimeter and fine, and download is fine. You can give it a name here, Hinged Box 01 top. So when you export it to that, that's what it's going to name it. And then go back to Part Studio 2, right click and say export. Hinge Box 01 bottom, export. Or if you want to do it from the assembly, you can just right click on the assembly 01. And if you want to, you can, didn't mean to press that key. You can rename this. You can call it Hinged Box 01. And now when you export this, it'll use that name here in the file name. This checkbox is normally on by default, export unique parts as individual files. You don't want to do that. I'll split them back apart here in a second. I'll show you that. If you check this, you'll get a zip file of multiple STL files. That's just going to be a little trickier to get uploaded into Canvas. So just leave that unchecked, and then I'll split them later once you upload the STL. So we'll export that. And now if we come to Orca Studio here, so now we'll create a new project, and I'll take, so if we start with like the part mode where we have the top and the bottom that we exported individually, I don't want to load these as a single object with multiple parts. I just want them as multiple objects. So now we have our top and our bottom, but we want the top flipped upside down. So I can say lay on face. Again, I can do this in the slicer pretty easily. You don't have to worry about it too much. And so now we have our two objects, our top and our bottom, that none of the angles are too steep. They're all 45s, and they should print pretty well. The other way is if you do it as an assembly and you export that, and you can see it still looks like the assembly. So what I have to do is split to objects, and now it's a similar situation where I just have to lay it flat on the top of that. So that's kind of some of the work I'm going to have to do on the slicer part, which is fine. And then we'll print these and use the filament as the hinge pin. So that's how you can go from Onshape and kind of model a box with a hinge and make it a little fancier, and then get that exported. One thing I did want to show is a weird idea I had. Come back to here. I thought, well, what about instead of making a box and always putting a hinge in a box, what if we put a hinge in something that doesn't normally have a hinge? And so that is a domino. And I thought, well, you know, dominoes, when you're playing a game and you stand them up on this edge here and somebody bumps the table, they can fall over easily. So if they were hinged and you could bend them a little bit, then that would make them a little less likely to fall over. So I designed this. This has some interesting features, I think, because it actually is a print-in-place hinge. It doesn't have a hinge pin that you put in afterwards. I could have done it that way, but instead I wanted to make it print in place. And so we have the left side here that has the hole here, but the hole is a little bit different in that it is angled at the top. And this is so that you get less drooping from having more bridging at the top of this. So this essentially won't have any bridging at the top of this hole, which will keep it from drooping down and touching the pin that's in the other part. So if we go to the other part, you can see that this one does have the pin print, in the design. That will print in place when it'll bridge across there when it prints, and hopefully will work well. So anyways, that's just kind of an example of what can be done. Print in place hinges are a little bit trickier because you do have to really, again, make sure your clearances. So I've got a small gap around everything in between the different hinges and all that kind of stuff. And but it did print, it did work. It bends a little bit, and it's kind of a funny idea. But anyway, so there's your random thing that shouldn't really have a hinge but does. Okay, well, I hope that's helpful, and let me know if you have any questions about any of this still. Thanks.